In the year 1905, a 26-year-old patent clerk in Bern, Switzerland, rewrote the rulebook of reality. With 4 papers, Albert Einstein dismantled our understanding of time and space, erecting a cosmic speed limit that has stood as the ultimate law of the universe for over a century. The speed of light, 299,792,458 meters per second. It is the absolute ceiling, the universal constant, the barrier that separates the possible from the impossible. We are told that nothing can travel faster than light. To do so would require infinite energy. To do so would break causality itself, allowing you to arrive before you left, effectively shattering the timeline. It is the one rule that physics seems to hold sacred above all others. But what if the universe has a loophole? What if the very fabric of reality doesn't play by the rules of the objects within it? While matter and information are shackled by Einstein's limit, space itself is not. There is a mechanism, a terrifying and awe-inspiring phenomenon that not only beats the speed of light, but leaves it standing still. It is happening right now, in the vast voids between galaxies. It is the reason the night sky will eventually go dark. It is the reason we are slowly becoming alone in the cosmos. Today, we are not talking about science fiction warp drives or hypothetical tachyons. We are talking about the expansion of the universe itself. The one thing that Einstein initially rejected, only to realize it was the greatest puzzle of all. If you want to understand the true scale of the prison we are living in, and the force that is tearing the walls apart faster than light can repair them, make sure you are subscribed to this channel. We are about to venture to the edge of the observable universe, where the laws of physics begin to fray. For most of human history, we believed the universe was static, eternal, unchanging. Even Einstein, when he formulated general relativity, found that his equations suggested a dynamic universe, one that was either collapsing or expanding. This terrified him. A dynamic universe implied a beginning or an end, and in the early 20th century, the scientific consensus preferred a steady, reliable cosmos. So Einstein added a fudge factor to his math, the cosmological constant, to force the universe to stay still. He later called this his biggest blunder. He was wrong. The universe is not still. In the 1920s, and at the Mount Wilson Observatory, Edwin Hubble shattered the illusion of a static cosmos. By observing the light from distant galaxies, specifically a type of star known as Cepheid variables, Hubble noticed something peculiar. The light was stretched. It was shifted toward the red end of the spectrum. Imagine an ambulance driving away from you. The sound waves of its siren stretch out, lowering the pitch. This is the Doppler effect. Light behaves similarly. If an object is moving away from us, its light waves stretch, becoming redder. Hubble realized that almost every galaxy he looked at was red-shifted. They were all running away from us. But here is the crucial detail that changes everything. They weren't just moving through space. Space itself was swelling. Think of a loaf of raisin bread rising in an oven. The raisins are the galaxies. As the dough expands, the raisins move apart. But the raisins aren't moving through the dough. The dough between them is growing. From the perspective of any single raisin, all the other raisins are moving away. And the farther away a raisin is, the more dough there is between you and it, so the faster it appears to recede. This was the first crack in the speed limit. Einstein said nothing can move through space faster than light, but he never said space itself couldn't expand faster than light. Space is the stage upon which the play of the universe is performed. The actors, stars, planets, you, me, have to follow the speed limit. But the stage manager can stretch the stage as fast as they want. For decades, we thought this expansion was a remnant of the Big Bang. Like a car coasting after taking its foot off the gas, we assumed gravity, the great attractor, would eventually slow this expansion down. The mutual pull of all the galaxies should act as a brake. But in 1998, two independent teams of astronomers studying Type 1 as supernovae, stellar explosions so bright they serve as cosmic mile markers, found something that defied logic. They expected to see the expansion slowing down. Instead, they found the opposite. The universe is hitting the gas pedal. The expansion is accelerating. Something is pushing the galaxies apart, overcoming the grip of gravity. We call this mysterious force dark energy. We don't know what it is. It makes up roughly 68% of the total energy of the universe, yet it remains invisible, undetectable, and utterly dominant. This acceleration leads us to a terrifying mathematical reality. The speed at which 2 points in space separate depends on the distance between them. This is known as the Hubble constant. While the exact value is currently a subject of intense debate in physics, a crisis known as the Hubble tension, let's use a standard approximation. Roughly 70 kilometers per second for every megaparsec of distance. A megaparsec is 3.26 million light-years. So, a galaxy 3.26 million light-years away is receding from us at 70 kilometers per second. That's fast, but it's nowhere near the speed of light, which is 300,000 kilometers per second. But do the math. Go further out. At 10 megaparsecs, the recession speed is 700 kilometers per second. At 100 megaparsecs, it's 7,000 kilometers per second. And at 4,300 megaparsecs, roughly 14 billion light-years away, the recession velocity hits 300,000 kilometers per second. This is the Hubble sphere. It is a cosmic horizon. Any galaxy beyond this specific distance is receding from us faster than the speed of light. Let that sink in. There are galaxies out there right now emitting light toward us, but the space between us and them is stretching so fast that the light is like a runner on a treadmill that is moving backward faster than they can run forward. That light will never reach us. Those galaxies are effectively disappearing from our observable reality. They are being severed from our timeline forever. Let's visualize this from the perspective of a single photon. Imagine a photon emitted from a galaxy located just beyond this Hubble sphere. This photon is the fastest thing in the universe. It has no mass. It experiences no time. It is pure energy screaming across the void at the absolute limit of causality. It is heading straight for Earth. But the void it travels through is treacherous. For every meter the photon travels toward us, the space beneath it expands by more than a meter. It is losing ground. It is running a race it cannot win. To an observer inside that distant galaxy, the photon leaves at the speed of light. To us, the photon is moving away from us, dragged back by the expanding tide of dark energy. This violates no laws of physics. Special relativity, Einstein's 1905 masterpiece, applies to local frames of reference. It says, you cannot pass a light beam in a race. It says objects with mass cannot reach light speed. But general relativity, in his 1915 masterpiece, treats space as a flexible, dynamic fabric. There is no limit on how fast the metric of space can change. This means that the vast majority of the universe is already lost to us. The observable universe is a sphere roughly 93 billion light-years in diameter. But the reachable universe, the places we could actually go, if we left today at light speed, is much, much smaller. In fact, roughly 97% of the galaxies in the observable universe are already beyond our reach. Even if we built a spaceship that could travel at 99.999% the speed of light, we would never catch them. They are receding faster than our maximum theoretical speed. We are trapped in a shrinking pocket of causality. If dark energy continues to accelerate the expansion, the consequences become existential. We face a scenario known as the Big Rip. Currently, gravity is strong enough to hold local clusters of galaxies together. The Milky Way and Andromeda are gravitationally bound. They will merge in a few billion years. The expansion of space is happening between galaxy clusters, not inside them. But if dark energy gets stronger over time, a scenario known as phantom dark energy, the expansion could eventually overcome gravity on smaller and smaller scales. First, the galaxy clusters would be torn apart. The Virgo cluster would scatter. Then, the galaxies themselves would dissolve. The stars of the Milky Way would be stripped away from the galactic core, drifting into the lonely dark. Then, solar systems would succumb. Earth would be ripped away from the sun. The expansion would happen so fast that light from the sun would no longer be able to cross the distance to Earth. We would see the sun vanish, not because it went out, but because space expanded faster than its light could travel. Finally, the expansion would overcome the electromagnetic and nuclear forces. Atoms would be torn apart. The very fabric of matter would be shredded by the expansion of space. This is the ultimate victory of space over light, a universe where no particle can ever interact with another particle again. A universe of absolute, cold, dark isolation. However, even if the Big Rip doesn't happen, even if dark energy remains constant, we still face a lonely future. As the universe ages, more and more galaxies will cross the Hubble horizon. They will accelerate past the speed of light relative to us. Their light will redshift until it becomes undetectable radio waves, and then silence. Future civilizations, billions of years from now, might look up at the sky and see nothing but their own galaxy. The evidence of the Big Bang, the cosmic microwave background radiation, the distant galaxies, all of it will have been erased by the expansion. They will believe they are alone in a static, eternal island universe. They will have no way of knowing that a vast, rich cosmos once existed. They will derive laws of physics that are wrong, because the evidence of the true nature of the universe will have receded faster than light, forever out of their grasp. We are privileged to live in a time where we can still see the echo of our creation. We live in the golden age of cosmology, simply because we can still see the lights before they go out. Just now you might be thinking, okay, space expands faster than light, but can we use that? Can we manipulate space to break the speed limit ourselves? This brings us to the Alcubierre drive, a theoretical solution to Einstein's field equations proposed by physicist Miguel Alcubierre in 1994. The idea is to do exactly what the universe does, but locally. Instead of moving a ship through space, you contract the space in front of the ship and expand the space behind it. You create a bubble of distorted space-time. The ship sits inside this bubble in a region of flat space, feeling no acceleration. It is not moving. The bubble is moving. And because the bubble is made of space-time, it can move faster than light. Mathematically, this is valid. It doesn't violate general relativity. But physically, it requires a form of energy that may not exist. Negative mass or exotic matter. We need something that has less than zero mass to create the repulsive gravity needed to expand space behind the ship. We have never observed negative mass in the macroscopic world. However, in the quantum realm, we see hints of it. The Casimir effect, where two metal plates in a vacuum are pushed together by quantum fluctuations, suggests that negative energy density is possible. If, and it is a massive if, we could harness this, we could effectively surf a wave of space-time, utilizing the same mechanism that drives the expansion of the universe. We wouldn't be breaking the light-speed barrier, we would be bypassing it. We would be making Einstein's rules irrelevant by changing the game board. But until then, we are stuck. We are stuck watching the universe run away from us. There is one other phenomenon that seems to mock the speed of light, though in a much more subtle way. It kept Einstein awake at night. He called it spooky action at a distance, quantum entanglement. When two particles become entangled, they share a single quantum state. If you measure the spin of one particle, the other particle instantly assumes the opposite spin. This happens instantaneously, zero time delay. You could separate these two particles by 1 billion light-years. Put one in a lab in Geneva and the other in a galaxy on the edge of the observable universe. The moment you measure the one on Earth, the one across the cosmos reacts instantly, faster than light. Does this mean information is traveling faster than light? For decades, physicists debated this. In 2022, the Nobel Prize in Physics was awarded to Alain Aspect, John Clauser, and Anton Zeilinger for proving that this effect is real. The universe is not locally real. Objects do not have definite properties until they are measured, and they can influence each other across vast distances instantly. However, there is a catch, a frustrating, brilliant catch built into the laws of physics. You cannot use this connection to send a message. Imagine you and a friend have two magic coins. If you flip yours and it's heads, his will instantly be tails. You go to Mars. You flip your coin, it's heads. You know instantly that his is tails. But you haven't sent him any information. He sees tails, but he doesn't know why it's tails until you call him on a radio, which travels at the speed of light, to tell him you flipped your coin. Nature seems to have built a firewall around the speed of light. It allows correlations to happen instantly, holding the universe together in a web of quantum connections, but it forbids us from using those connections to cheat causality. It's as if the universe is saying, I am connected, but you are not allowed to know how. So, was Einstein wrong? Not exactly. He was incomplete. His speed limit holds for you, for me, and for every atom in our bodies. We are prisoners of the light cone. We are bound by the speed of causality. But the cage itself, the space-time we inhabit, is not bound. It is wild. It is expanding. It is tearing the cosmos apart at speeds that make light look like it's standing still. The one thing that beats light speed is the nothingness between the stars. It is a humbling realization. Yes, we often think of light as the fastest thing there is, the hero of the universe that illuminates the dark. But the dark is faster. The void is winning. The expansion of space is the dominant force in the long game of cosmic history. Every second you have been listening to this, millions of miles of new space have been created between the galaxies. The universe is getting bigger, colder, and lonelier. We are living in a brief, shining moment where the universe is still connected enough to be understood. We are the lucky ones. We can see the galaxies before they flee into the shadow. We can measure the light before it stretches into silence. The speed of light is a limit, but the expansion of the universe is a destiny. And in the race between the light and the dark has the advantage of the ground itself. moving beneath its feet. If you want to keep exploring the terrifying beauty of our cosmos before it expands beyond our reach, make sure you are subscribed. The universe is vast, and we have only just begun to map the dark. Thanks for watching.